Hello again. In this video, we're going to continue with section 6.2. We're going to look at the graphs of exponential functions. We're going to first do them by hand by filling out the following tables. So go ahead, let's start with A and C, since it's all on the same page here. So go ahead and pause, fill out the tables, plot the points, and come back when you finish that and see if you can come up with the graphs on your own. Okay, are you done? Here's what I got. I'm going to start with plugging in a 0 because I think it's easier, and that is just 2. And how do you get that? That's y equals 2 times 3 to the 0. Well, we know 3 to the 0 is 1, so that's where you got the 2. Plug in a 1 is 6. How do I get that? I'll do it up here. Y equals 2 times 3 to the 1. And that would be 3, just 3. 3 times 2 is 6. And finally, this one is 18. Looks like we multiply by 3. The growth factor is 3. That makes sense because you have a 2 here. You have to square the first as well. That would be 9 times 2 is 18. The negatives are a little tougher. 3 to the times 2 to the negative x, that would be 2/3, and this would be 2/9. How do I get that? Y equals 2 times 3 to the negative 1, and if you remember what 3 to the negative 1 is, it means 1/3. So 2 times 1/3 is 2/3. And finally, I can do this last one. 2 times 3 to the negative 2, so that would mean 2 times 3, whoops, let me rewrite that. That means 2 times 1 over 3 squared. I don't know if you could see that, which is 2 over 1 times 1/9. So that's how you get those. What happens when you plot them? You can label the y coordinates anything you want. I'll just count by 2, since 0, 2 is right here. 1 is 6. 2 is 18 is off my grid. We could have counted by 3s if we wanted to get to the 18. Negative 1, though, is 2/3. So 1 is about there. So 2/3 is a little less than that, and 2/9 is even smaller than that. We're just looking for the shape, so we don't need all the points if you don't want. It looks something like that. That is what an exponential growth. This is a growth, by the way. It's a growth because the A is bigger. Sorry, the B. The B is bigger than 1. If you remember from the last section, A times B to the x, and A is the initial amount and B is the growth or decay factor. The answer to these, this would be 200. I'm going to start with 0. This would be 100, and this would be 50. It looks like we count by 50s. So just to do one of these, I won't do all of them on this one, but if you have 0.5 to squared, for instance, what does that mean? Well, 200, you could just use your calculator, but that means 1/2 squared, so that would be 200 times 1/4, so it would be 200 over 4, which is 50. So plugging in a negative 1, this would be 400, and this would be 800. I know the growth factor is 2. Again, seeing one of these, you would get y equals 200, I'm going to draw a line right there, times 0.5 to the negative 1. That's kind of weird to do. Again, you could just use your calculator, but I'm going to say it's 200 times 1/2 the negative 1. If you remember in our exponent sections, that flips that, doesn't it? So that's why it is 400. Plotting these, I'm just going to count by 200s, but again, you could count by 100s, but somehow you want to get to 800. Negative 2 we know is 800. Negative 1 is 400. 0 is 200. 1 is 100, so that's halfway between, and that's 50. So there's 100, so 50 is even smaller than that. That is what this looks like. This is a decay. This is a decay since b is smaller than 1. It's getting smaller. So the 3, we keep on multiplying by 3. But this is 0.5, so we keep on multiplying by 0.5, or dividing by 2, which makes it smaller. If you didn't get those, now try these. Same 2 ideas. I'll just show you a solution in a minute, so pause it, try it, come back when you're ready. Are you ready? Okay, here's the solutions. So here's part B. Plug in 0, 1, 2, and then you could just use your calculator. I decided to count by 5s. This one's a little more tricky, so let's go ahead and do this one together. We haven't done one like this. Plugging in a 0, I'm going to start with that, is 270, because anything to the 0 power is 1. Plugging in a 1, we haven't done a fraction yet, we did a decimal up there. Means putting this over 1, it's like dividing by 3. So that would be 90. This is going to be, now you get the idea, dividing by 3, multiplying by 3, and multiplying by 3. So, just to see one of these, y equals 270 1/3 to the negative 1. What does that mean? That means 270. We can flip this. We learned that in Appendix G. That would be 3 over 1. So it's just 270 times 3, which is the 810. So I'm going to count by maybe 200. I'm not going to try to graph that. As long as I get most of my points, I want to at least get to 800 there, so I don't miss 2 of them. So negative 1 is a little over 800, very tiny. 0 is 270, so there's 300, so a little under that. Just trying to get a ballpark picture. This is a little under the 100, and 30 is below that. So again, this is a growth. You can see it's getting bigger, and the a equals 2, which is bigger than 0, or bigger than 1. Did I say bigger than 1? Yep, great. That's that one. This one is a decay. It's decreasing, it's getting smaller. And, oh, it's not the a, it's the b. The b is equal to 1/3, which is less than 1. It's a decay. It's getting smaller. So just like up here. So in general, if a and b are both bigger than 0 and b is not 1, then the graph of a times b to the x has the has a y-intercept. Oh, the y-intercept. So let's look at these two. The y-intercept was 5. That's this number. The y-intercept was the 270 here. Let's look at these. Right, the y-intercept was 2, was 200. So it looks like A, that initial amount, is the y-intercept. The initial amount. It has no x-intercept. Notice how it never crosses the x-axis in all the graphs above. And by the way, it's increasing if the b is, the growth is bigger than 1. And that means it's a growth. And it's decreasing if the b is less than 1. And that's when it's a decay. So let's go ahead and try the next page. Exercise 6. It says let P equal f of t be the equation 10,000 times the factor 1.025 raised to the t. This gives the population of a town t years after 2005. Evaluate each expression and say what it tells you about the town. So go ahead, pause, try this, and come back. Are you ready? What is f of 0? We've done this before. I'm just going to plug in a0 there. And again, just like the table, anything 0 power is 1, so that is 10,000. And what does that mean? It means that the population is 10,000 at the beginning, which was, by the way, in the year 2005. So what about f of 1? Plugging in a 1, you get 10,250. And what does that mean? It tells us that the population with 2,000 in 2006 was 10,250, 1 year later. This is a challenge problem. Which ones of the following are exponential? And if they are exponential, if so, identify the values of a and b. And don't forget, y equals a times b to the x. So the a would be the initial amount, and the b would be the growth or decay factor. So which ones are exponential? Pause it. Let's just answer that question first. And come back when you think that you know the answer. You can go ahead and circle them. They're exponential whenever there's a variable in the exponent. So A, B works, even C. The following three here, well, actually, D is no. E is no. Both of these, if you look at the exponents, they're numbers. But F is a yes. We'll go ahead and do the first one together. How would you, for the second part, identify the A and B? Well, I would rewrite this as Q is equal to 4. Bring that up to get a negative T. Or, maybe even better yet, make it like that, which would be a 1/4, which we could have actually said in the beginning, I realize. So here the A is the 4, and the B is 1/4. So now pause it, see if you can do B. Did you get it? Here's the solution. So I did the same thing. I made 2 to the negative 1 times t, because it's the same thing. Made the 2 to the negative 1 and 1/2. And then clearly now the A is the 1/3 and the B is the 1/2. Let's go ahead and do Q to get C together, because this one's a little more challenging. We haven't done this yet. What I would do is use my ideas of radicals. If you remember, a square root meant to the 1/2 power. And then I would use my idea of exponents, all from the G appendix, and distribute that through. And then this is a good answer for my A, but I'm going to do one more thing here and make this a 1/2 raised to the T, so I can see that my A is 5 to the 1/2, and my B is 4 to the 1/2. By the way, you could write it like that, or you can write A is square root of 5, B is square root of 4, which, by the way, square root of the 4 is 2. So B just turned out to be 2. So now try F. You don't have to identify the A and B for the D or E, since they are no, not exponential, not exponential. Did you get it? Here is the solution. Here's the solution. Did the same thing, very tough, raised it to the 1/2, distribute in the 1/2, just like we did above, but now I have a T in both, so I distributed, I went backwards and raised it all to the T, because that would be the same as that. And I just simplified the inside. 4 to the 1/2 is the square root of 4, just like above, 2, so it's 5. So it turns out that the A is 1 and the B is 5.